starts with AL. This is like using like and then first giving the first two values and the percentage sign. If it starts with AL, it will give us out. Yeah. So this is group by. So here what we are going to do is we're going to group it by sex. Then this is different from SQL. So in SQL, let's say no, this is also similar to SQL. In SQL also we could group by. So in the back end what happens is in using the data frame, if we group it by a particular column, it will convert this to an object, to a group object. So I will show you that. See, this is an object, group data object, and this is the position that it takes. That is not important. So the important thing is it converts it to an object, and then from that object we are using .agg and getting and then giving multiple aggregate functions inside on this particular object. So basically I'm telling it I want to aggregate, and these are the functions that I'm going to give to aggregate. Yeah, that is happening here. Then yeah, so this is how you get today's date, as in similar to get date in SQL. Here we have current timestamp, so that will give us today's date. Yeah. Then yeah, so here what I'm doing, basically what I'm doing is I'm adding. So to this date, I'm gonna add 7 days. So I did this yesterday, so one more day today. So from this particular day, I'm adding 7 days. That is happening here, and then from so here we created the date column. From that date, I'm extracting the year. If you want month, you could replace the year with month. You will get the month, day, all of that you will get here. So that is about dealing with date. So this is okay. So next we have this is nothing but sort. We already saw what is sort, and similar to sort, we have order by also. So here, so somehow this is not working in this particular cell. Yeah, but that's the two code for sorting. One is if you could use order by, or you could use sort, and then call the particular column, and then use ASC, and then if you want to sort it using some other column, and then you want to sort that column in the descending order, you could do that as well. Yes, that is happening here. Okay, so now coming to window function. So you must already be knowing window functions in SQL. We have row. Yeah. There are multiple types of window functions. Yeah. So here we're gonna see running total, rolling average. So these three we're gonna see. So to start with, basically here we are defining the window. So here I'm partitioning by sex and then ordering it by age. This is just a rank function. And then
you don't need like you can. Do you need to use rank with window function? You can use rank directly, right?
Yeah. So here what I'm you could use a rank directly, but here what I'm doing is I want to partition it based on sex and show you how the rank functions. Let's say if you want to get what so from a group you want the oldest member, so I could use rank, and then finally I could from here I could filter it out where rank equal to 1, and I'll get the oldest member in each group. So that is what happened here. Yeah. So here what I'm doing is you should already be knowing this with column. With column is to add a new column. So I'm adding a new column named rank, and I'm calling the rank function, and I'm using the over clause, and then I'm defining and I want it over this particular window. So in this window, so for the first one, there's only one. So the rank is one. And in the second one, I have one and two because this is the oldest. This has 56 and then this is 50. So that is about a rank function. Now similarly, there are three types of functions. One is three types of window function. One is the ranking, one is aggregate, and then we have analytic functions like lag, lead, all of that. So the second one we're gonna see is the aggregate function. So this is running average. So here there is something called unbounded preceding. So by running total, what happens is, say if in here, so here also I'm partitioning based on sex. So here, the first one, it will be just this one. The second one, the first record, it will be 50, and the second record, it should be 50 plus 56. And if there's a third record, it should be 50, 56, and that record. So how to calculate that running total is here in the window, I'm defining the window as a dynamic window, and I'm saying all the particular records in my window till my current record. That is about unbounded. That is unbounded proceeding. All the records above till the current record. So that I'm doing here, and then I'm taking the sum over this particular window. That's running total.
So you can do moving averages with this also, right? Because every time a data element gets added, you can create the moving average, rolling average, or what you
Yeah.
call it.
Huh. Yes, rolling average. That's the second thing that I was gonna say. Yeah. So there also, if you give unbounded proceeding, and then and this zero, what the zero signifies is your current row. So you could use that, create a dynamic window, and it will function on its own. So here, what I did is here I took rows. So the two rows above and my current row. So that is the average that I'm taking here, but I don't have two rows above. So here, the first two will be same, and then coming to, so don't look at this rank. This is from the earlier one.
Okay.
So here, yeah, and then let's say
So
in
when you
the third
say
one, I'm taking
rows between -2 and 0, what does that mean exactly? Like I didn't quite understand that.
the two rows above my current row.
Okay, it'll give you the rolling average for 2 rows above the current row, is it?
Correct. Yeah. Okay. Window is not defined. I have to execute this. So before executing the window function, you need to import window. Before using rank, you need to import rank from PySpark.sql.window. Okay, so this is a library, and then from this library, we are importing this particular module.
Okay.
Yeah, so that is happening here, and then okay, so in order by like how we used to use col.pds. Yeah, so that is happening here. That is rolling average. Then the yeah,
So
you
just one
have
second, right? So when you say, can you scroll up? I just want to look at that window. That so you're partitioning by, okay, by sex, order by column, okay, and then you're saying rows between -2 and 0. So
it need not be always -2. I just took an example. It could be -1 as well. So just
so
the row
minus,
above. Yeah,
okay. So it'll just to give you the average between the rows above and the one and the current row.
correct, correct.
Okay, and you
And
can
that
do,
order is, and this defines the order. And yes, you can do.
okay.
Yeah, sorry, you were saying you can do what?
So like for instance, on the first cell, age 25, so it's giving 25 because it's the first one. So
Mm.
second column, second you have age 56. So it should give
No,
25 and 56, right?
I have partitioned
Average.
by sex type. Here I have partition by
Uh,
sex. This
okay.
could be one partition. That is why it's giving this thing. And these
Okay.
two are
That
one
makes
partition. Yeah. Okay. Next thing is join. So this is one of the best practice that you could use, and this will be more efficient also. That is broadcast joining. So let's say you have one data frame, a small data frame, and you have a large data frame. So it is advisable to do broadcast joining when one of the data frame is small. So what broadcast join does is it takes your particular data frame and it sends that data frame across all of the nodes. So you know the architecture right now, right? There will be a driver node, worker node, and inside the worker node, there will be multiple cores and all of that. So to each node, we will be sending a copy of this data frame. That is broadcast joining, so that we could reduce shuffle.
okay.
Yeah. So shuffle, if you remember from last session, is nothing but whenever one node needs data, uh, needs data, and it doesn't have the required data. So in that case, the data has to move from other node to this node. So then that data movement, we call it as shuffle. So to reduce that data movement, we have we could use broadcast join, but it sends the whole data frame to all of the node. So if both data frames are huge, we should not use broadcast join because it will have negative
Oh, okay.
implication. Yeah. Then here now we're gonna see about user defined functions. So, but I'll tell you as in as per these are user-defined functions, but it is not very advisable to use user-defined functions. I'll tell you the reason why. So the first part of one second. Let me see if I have missed anything in my notes. Yeah, we have seen logical expression. So we have seen grouping and aggregating data. We have seen yeah the case when also we have seen window function processing. Yes. Yeah. So, okay, coming to UDF. So, UDF are basically to apply custom transformation to a data frame. So, first thing is first we need to define the particular UDF. So here what I'm doing is I'm using the upper function and converting, so whatever I'm defining here, I have to convert that to an upper function. So here I'm defining my UDF. And then in second line, here from this library I'm importing a UDF module, and here I'm registering my UDF. Yeah, so first we have to define the UDF, then we have to register the UDF, then we could use the UDF in our normal code. So here now what this does is it takes each of the record and then it applies whatever function we have defined here, and then it gives us the output. So if you see here, it will convert our name. It goes here, it applies upper function and converts the name into uppercase. But why I said we should not be using this is we should be for because we'll be dealing with large number of data, so large data, and then to do the transformation in a row by row manner is not at all efficient. So this should be our last resort.
So when you say row by row, I didn't understand. What don't doesn't all transformations happen row by row?
No. So these transformation happen in bulk. So this let's say what let's take any transformation. So even if you're using filter transformation also, it takes the complete data, and then from the whole data it just picks whatever data is required. But here what happens is it goes into each row, iterates each row, and then gets us the output. Where is that?
Okay, so it's
That's
basically
about
applying
user
UDF to every row one by one. It's going.
every
Is
row.
it?
Yeah. And the
So
whole
when you're
idea
using
of
Sorry,
No,
good.
please go ahead.
So I was saying that so in other cases like filter, you were just it was just able to apply to that particular whatever the value is looking at. But here every row it will be going one by one. Okay.
Correct. Yeah. So it iterates through each row, so that is not at all efficient. Yeah. So the next thing we're gonna look at is how to handle null value. Here, what happens is, say if we have any null value in any column, then it will basically drop that particular record. And say initially it will be going in record level, but if you want, we could define another access also. And if we give access equal to 0, okay. So yeah, so drop and I have to check. Yeah, I'll check this out, and then when I'm sending the note, I'll send it to you. So basically what happens is there is a parameter inside, and when we give that particular parameter, it will check between the if say if any of the rows in one of the row, if we have a null value here, instead of 56, if we have a null value, it will drop the it will drop record 2. That is drop NA. But if we are specifying another access, and then if we have as in if we are specifying the columns, and if 56 is having null value, then it will drop age column. So that is drop NA. And then how to switch between access, that I'll tell you. Then the next thing is fill NA. So fill NA is nothing but if there are null values on any of the columns, then this will basically fill that particular column.
It'll fill it with NA, that's it.
Yes, if you want to fill it with some other value, any other string, you could do that as well. That's it. The drop NA, when I send you this notebook, I'll update it and send it to you. Yeah. So this collect is important, but collect also you should not be using, because that I'll tell you why. So let's say here what I'm doing is, from this particular name, data frame name, I'm converting it to an array and getting the first element. Yeah. So this is the second element, and then this will be the third element. Okay. Right now there are just two. Okay. So that is happening here. So this is basically, so let's say you have done a ton of transformation, and finally you want to show just the string value as output. Then you should be using collect. So it will basically convert it to a two-dimensional array, and then it will give you the value. So these are rows and these are columns. We only have one column, so that is why it is giving you this, because I have selected name alone. So if there are multiple columns, you could access the required value here. Yeah. Then the next
Others,
thing is
we are above. Yeah, we are above our time contract. Others, it's past
yeah.
10:30.
So just yes, I understand. Just give me just two more cells. Will be at done.
Okay, two more cells. Okay.
Yeah. So here, what happens is, okay. So here, how to change the date format. That's what you are seeing here. So let's say we have a particular date, and then if you want to convert it to year, it is very self-explanatory. Year, month, date. That's how we change it here. This also the same thing. So there are other functions. So here we use date underscore format, or we could use to underscore date. That's one other way. And this is date underscore sub is to subtract the date. Earlier we saw date underscore add to add more dates, and then date diff is to find the similar to SQL function, to find the difference between dates. Yeah. So in this date sub date add, you could add more parameters and show if you want to add month, you could specify that and then add month. Yeah. So that is about it. We have completed both the modules. So let's see if I have missed any. Uh, Column class, working with column expression. We have seen in detail all of the expressions. Yeah.
Is there a
Uh,
proper like a cheat sheet of all the, like I can use your notebook, right? That itself will be the
yes.
all the.
Yes. Yeah. Cheat sheet, like cheat sheet. I haven't found any till now. I'll check that if I have any cheat, as in if it's available in the internet. But yeah,
Yeah. Okay.
I had to search multiple sites and get all of this.
Okay. So that's how you have to do it. Yeah, that's a challenge, right? Like I think with PySpark also, like it's not like everything's not available. Like for SQL, right? If you open one thing, there's like a proper dictionary. You can find everything in one place.
Mm,
So when
correct.
you're
Correct.
doing any coding, right, you can just directly start. You can look at that and you can use that guide and you can easily code. But with PySpark, it's a challenge, right? It's so many different ways of approaching a problem.
Correct. Correct. Yeah. Yeah. Then we have to choose the most efficient one.
Yeah,
That's why.
and
So
because yeah,
that
we'll
is
be
the,
we'll be working with millions of rows, right? So
yeah, correct.
small changes will have significant impacts.
Yeah. And one more point I have to tell you is why I told you we should not be using collect. I'll tell you why. So what collect does is it takes all of the data and then it brings it into driver node. You know the architecture, right? Driver node and worker node.
Yeah.
Worker node should be the one that should be processing, but it takes all of the data and puts it back to driver node. And then because of this, there will be memory issue and performance with degradation. So that's what happens when you use collect. The collect and the UDF we should use only as a last resort.